Good morning, everybody. My name is Miles McLean. I am one of Snyk's Senior Solutions Architects, and I'm going to be giving this brief webinar today on the Snyk platform and kind of what we're all about. In the event that you have a question or you want to know more information about something that I talk about, feel free to use the chat in GoToMeeting here, and we'll try to address some of the questions at the end of the session. I'll leave a couple of minutes for questions, and anything that we don't get to in that session or in that question time there, we'll reach out to you and close the loop a little bit afterwards. Okay, so first things first, Snyk is a relatively young company. We've started just about 5 years ago. In that time, we've raised quite a bit of capital. We've hired a lot of employees. We're around 300 employees by this time, and we have about 400,000 organic users. These are people that have come to our platform to actually sign up and get security directly. These are mostly engineers coming directly to the system, something that a lot of security companies, I think, wouldn't be able to say. We do have two distinct products today that we offer. One of them is Snyk Open Source. This is for protecting your open source components or protecting your software from your open source components. And Snyk Container, which allows us to detect vulnerabilities in your containers when they're being built during that process. From a story perspective on what it is that we're actually trying to solve, the issue here is that most software built today is dependent on open source libraries coming from somewhere that is not your internal development team. They are including libraries that come from GitHub or from other open source dependency library areas. They're including them with their packages, and then that expands the code base pretty exponentially. This code base is something that your engineers are not necessarily directly responsible for. They didn't build it, but they did include it, and there can be attack area inside those libraries. There can be other vulnerabilities and other sorts of exploits that come from there that your employees or your engineers just generally don't see. Snyk is that eye over your shoulder that's going to be there to look at those packages and tell you whether or not there's any kind of vulnerabilities, and also give you a path out of there, usually by upgrading the vulnerabilities or upgrading the libraries that have vulnerabilities, or bringing in other libraries to replace them. The way that we do this is we start with a developer focused approach. We come to the developers where they're at with their pane of glass and try not to force them into a different area that they're not necessarily used to. Most engineers are not going to be security personnel. They don't understand concepts like what a CVE is or why they need to be concerned about these kinds of vulnerabilities. And so Snyk changes the language a little bit, and we change the tooling to come to the developers where they are at. And we build things that developers might actually want to use early on in the process. This allows us to enable this shifting left strategy where developers are taking ownership of security in their code way before they've even shipped it upstream and way before it makes it to the security teams. So we do this with command line interface applications. We do this with IDE integrations, plugins that drop directly into IntelliJ or Visual Studio Code, that sort of thing. And we want the developers to feel like they've got tooling that they understand and that they can use front and center. While we're sitting there on their code base and we're watching this application get built out, we take a look at the manifest files that are basically the dependencies of these applications that are being built. So we would look at, say, the package.json on a Node application or a pom.xml file if we're dealing with Java or that sort of thing. And Snyk is able to extrapolate what the dependencies are that are being brought into this application, and that's how we're able to tell that developer that something is going wrong. The next thing that we're able to bring, this automation, is really because we're able to watch those manifests get built out. We can tell the developer not only that something is broken, that a new vulnerability has been introduced, but also the version that something is being fixed. And so they know exactly what the upgrade path is that they need to take. In a lot of cases, we can even go a step further, and because Snyk knows what that fix is, we can just do the fix for you. We do this by creating automatic pull requests or other things like that in, say, your GitHub or your GitLab, and the fix will automatically be there. Your code maintainers just have to review it, test it, and merge it, and then that vulnerability is taken care of without any kind of overhead on your developers. And then kind of the final pillar is that at the bottom of all this, we are a security company at heart, and we have a database that's really unmatched in the industry. What we do is we aggregate vulnerability data from all the upstream public databases we can find, NVD, CVE, that sort of thing. We pull that data in, we aggregate it, and then we complement it with proprietary research from our own security teams. We'll do things like look at the top 10 packages on NPM this week, and we'll try to find our own proprietary vulnerabilities. We have partnerships with academia and other institutions that will responsibly disclose vulnerabilities through us. We're a CVE numbering authority, and so we can take that vulnerability all the way through the proper channels to make sure that it's properly disclosed. And then finally, we have some tools internally that we call threat intelligence, and this is little more than some scraping algorithms that go out to the internet and they search for keywords and phrases, things like comments on a GitHub issue or tickets in Jira or that sort of thing, and we'll detect keywords like I've fixed cross-site scripting issues or something like that, where we've been able to see some kind of an indication that a security issue existed and has maybe been remediated or maybe is being worked on remediation. In a case like that, what we found is that a lot of these upstream developers building these libraries are not security experts either, and they don't know that there's a process that needs to be followed. And so our security team can help triage and work with those folks to properly disclose their vulnerabilities to the appropriate channels. Of course, it makes it into our database first, and that goes in with the rest of our aggregate data. But then we're able to protect the rest of the community as well because we've gone through the responsible disclosure process. Once all these items are inside our database, our security team hand triages every single one of them, and we bring in a lot more information than just the fact that there's something wrong. This is where we're going to figure out information like when the vulnerability is actually fixed, what those minimum versions are there backported fixes. We're going to be able to figure out information like whether there's exploits actually in the wild for this specific vulnerability. We're going to aggregate a lot of this data that we can kind of present back to the developer in order to help them prioritize when these things need to actually be fixed. We've talked about Snyk fitting onto that left side of the SDLC, right? Obviously integrating directly into the developer's workflow, and that's kind of at this code side, the far left side here. We want to fix vulnerabilities as early as possible because it's cheaper and easier and quicker usually to do it there. But that doesn't always happen, and so Snyk is able to sit into the rest of the SDLC as well, all the way through to production. We start at the next step after code, which is of course the Git level, where code is getting shipped upstream. Snyk has plugins that drop directly into GitHub, Bitbucket, GitLab, Azure, most of the major platforms that are out there, and then we've got tooling that can work with other providers as well. And what Snyk will do at this level is kind of twofold. The first thing is that we'll set up automatic tests for any projects that Snyk is monitoring. This makes it so any new pull requests or merge requests that come into your environment are automatically tested for license issues or for issues with your open source dependencies. And then, of course, your own ruling internally can break builds or it can break merging based on the results of those tests. The other thing that we do is we proactively monitor those repositories day after day, every 24 hours at minimum, to tell you if there's any new 0 days or anything else that's being introduced into your code that wasn't there the day before. At the next step, we're in kind of the CI/CD level. Our code is trusted, but we want to validate it because this is kind of the last effort before we go into production. So Snyk is of course able to drop into most of the major CI/CD providers. We've got plugins for Jenkins and Circle and that sort of thing. Again, we've got tooling that allows us to integrate with pretty much any custom CI/CD pipeline that you have out there, even if it's hand scripted and bashed, no big deal. And what we're going to do here is we're going to, of course, detect vulnerabilities or license issues or anything else during build time, and you can break your build if we detect vulnerabilities. That's typically how we see it. The other thing that happens is that we're able to take a snapshot of your open source dependencies at this point that is typically a representation of the build artifact that's going to go out to production. This way, Snyk can monitor that artifact day after day after day without us actually having to sit on your production servers. We're not having to run any kind of monitors or thin clients or anything like that in your production infrastructure. We know what got shipped out. There's an assumption that we're taking modern DevOps approaches and things like that in place here, but if your workflow calls for this, then Snyk is able to properly monitor your production enterprise without actually being in production. We do have some other fingers in the pie here in regards to Kubernetes and some of the other integrations here where Snyk will actually sit inside your Kubernetes cluster or things like that to try to watch security. But in a traditional sense, we try to stay pretty light touched, in regards to the way that we do security. I'm going to actually jump into the platform now and show you where the rubber meets the road, talk about what Snyk actually looks like and how a user actually interacts with the product. So on our main page here, I'm on a projects page for my organization. This is kind of my group in Snyk, and these are the projects that my group is responsible for. If I wanted to add new projects or have Snyk monitor something new, I would click on add project and then I would select the upstream source wherever this is coming from. I can also tell Snyk that I want to integrate with something else and have Snyk connect to a different type of service. Each one of the cards that we see here, for lack of a better term, is a wizard, right? We drive into one of these things and then Snyk is going to give me some boxes to fill out. It's usually API keys or some kind of a username and password, and Snyk does all the heavy lifting behind the scenes to connect the pieces here and make this whole thing work. So we see that Snyk has got connections for all those Git services I mentioned earlier. We can connect directly to your container registries to scan your Docker images remotely, connect to Kubernetes and your CI/CD, so on and so forth. We have alerting channels over Slack or Jira, and then in the future we have some webhooks coming that will allow you to be able to connect to any other service you want to as well for notification purposes. In my case, I've already got GitHub configured, and so I'm going to onboard a project from GitHub and show you what this looks like. So I'm a user who wants to bring a project in for Snyk to monitor. I would click on GitHub here, and it's going to bring me to a screen where I'm able to select the projects that I want to onboard from GitHub from the organizations that I'm part of in GitHub. In this case, I'll open up this here. And this will bring all the projects that are inside my organization. I've got quite a few, so it takes a second to load here. There we go. In this case, I can select all the projects that are inside my organization, onboard them all at one time if I wanted to, or I can just individually click the ones that I want. In this case, I'll bring this Goof application online. I click on Add Selected Repositories. And what Snyk will do here is it's doing the onboarding process, which is kind of twofold. That first thing is that it's setting up those automatic webhooks in the GitHub side of things. So anytime a new pull request comes in, Snyk is going to test this repository for new license issues or new vulnerability issues. I don't have to be a DevOps expert or an engineer to set up those sorts of tests or automation. Snyk does all that heavy lifting. The second thing is that Snyk is looking through this repository and is trying to identify those manifest files that I mentioned earlier. So these are those package.json files or the lock files or the things that represent what the open source dependencies are that are coming into this repo. Once Snyk has found those and categorized them, it'll show them up in this list like this. So in this case, this application has 3 of them. Snyk has found all 3. The one that I just onboarded only has 1, and that's the one that I found here. But Snyk is able to kind of separate these and roll them out for different responsibility groups, that sort of thing. In this case, I'll drive into the package that Snyk was able to find. And we see that at the top, we've got a high level overview on exactly what the results are here. This package.json that Snyk found, I can tell you it's got about 20 direct dependencies in it. These are things that my developers have included directly to make this application work. Snyk extrapolates those dependencies out and it actually builds the full tree to tell you what the transitive dependencies of those direct dependencies are, what the transitives of the transitives are, et cetera, et cetera. What we find out is that those 20 end up turning into 471 unique types of unique libraries that are brought into this project. And out of those 471, there are 53 unique vulnerabilities that Snyk has found, introduced 245 different ways, so the same library coming in from different transitive paths. If we click on the Dependencies tab, we actually get a visual representation of exactly what this looks like. We can see visually, how did these transitives that have these vulnerabilities come into being inside my application? So we look at Negotiator here, for example, we see Negotiator wasn't actually included by my developer directly, right? My developer included Error Handler. Error Handler included Accepts, which includes Negotiator. This nesting and being able to resolve this sort of thing out is important for Snyk for a couple different reasons. First of all, we want to be able to tell you how this actually came to be. Second of all, this is how we do resolution. When we go to try to fix or tell your developer how to fix Negotiator in this case, usually the solution is to actually upgrade Error Handler, not Negotiator directly. If we upgrade Negotiator, that typically consists of having to pin Negotiator into your package manifest or introduce a hard version, and we're not allowing the package manager to really do the work. And so we take it a little bit higher, and that's part of that data that we track in our database. We kind of understand the way that things are actually brought in, and then we're able to resolve it out in a healthy way that makes sure that your packages don't actually break in their dependency trees. On the Issues tab back here at the beginning, we have more of a security view on exactly what it is that Snyk finds. We see each one of these individual cards represents an individual issue or vulnerability that Snyk has identified here. And then we get a bunch of high-level information telling us how to prioritize this or how do we take this information and make it valuable to our engineers. At the top, we of course see our severity level, that sort of thing. We see things like exploit maturity. This is whether it's actually being exploited in the wild today. Mature represents that it is, as opposed to proof of concept or no known exploit, that sort of thing. For certain languages, we have reachability info. Is this something that's actually being utilized in your code base? Are you actually calling a function that uses this library or something that's specifically vulnerable here? We give you some text-based remediation if you wanted to see exactly how these things are fixed textually. And then we also have an overview. Maybe you could look at this and see, that this is something that I'm using because I know what this functionality is. If you do want additional information or you want to know from a more security-sided perspective exactly what this vulnerability is getting involved with, you can dive directly into Snyk's database and see all that information right here. This is all the information that Snyk security team has curated. So we of course get all the upstream CVSS information, we get the upstream CVE, we get any kind of the original reports or information from when this was originally announced, and that sort of thing. Again, all this information kind of in the name of helping your team prioritize when vulnerabilities get fixed. And speaking of fixing things, if we're in an event where the developer is not able to fix something or you're a non-technically minded person who wants to fix something, that sort of thing, we can also have Snyk manually create a fix for each one of these issues if it's supported. In this case, we see that this card, for example, has this fix this vulnerability button. I can click on this link here and it takes me to a screen where I can select all the vulnerabilities that are part of this project. I can select one or many, as many as I want to have Snyk try to fix for me. And then I scroll all the way to the bottom and I click on Open a Fix PR. This is going to have Snyk do the heavy lifting on this fix. And what we end up with is a PR that looks like this. On our conversation tab in the pull requests, we get a lot of the same information that we saw kind of on the card view. And the idea here is that a lot of the people who are maybe managing the pull request or actually during the merge process might not be security personnel. They might not log into Snyk. And so we're trying to tell them information that's relevant to the merging process. In this case, do we detect that this might be a breaking change? Is this a major version change basically on this library? What's the exploit maturity? How quickly should we merge this? And that sort of thing. So we try to give them as much high level information as we can. The changes themselves are usually pretty trivial. In this case, Snyk knows that this specific vulnerability that we were trying to fix is fixed right here. This was for this package ADM zip as an example. What we've done is we've taken the 0.4.7 version and we've upgraded it to 0.4.11. Not a lot of logic that actually happens here, but we do upgrade the other files that are dependent on this. In this case, a lock file because this is a node application, that sort of thing. The other items that you see in here are for a different type of fix that we're doing. So Snyk can obviously upgrade the versions like you see here. In some languages, we can also help protect you by patching the vulnerable versions of your libraries. In this case, we see that there's a library that I've patched, this library MS. In whatever case or for whatever reason, the upstream maintainer of MS hasn't released a new upgrade that fixes whatever the vulnerability was that I clicked in this specific pull request. So Snyk has actually introduced a patch to fix this vulnerability. If you wanted to know exactly what it was that Snyk is doing behind the scenes, we see here on the conversation tab exactly what this fix is. We can see this is fixed with an upgrade, this one was fixed with a patch. We see the differentiation there. I can click on the patch version and it takes me back to Snyk's database, that screen we saw earlier, and I can go as far as even seeing the physical patch itself. So if we had a different mechanism to apply patches or something like that, you don't want Snyk applying security fixes directly to your code, makes total sense. Come get the patch directly and apply it another way, that's perfectly fine. I'm going to head back over to Snyk's platform, and we're actually going to switch windows for just a quick second here. And we're going to talk about what this looks like from a developer's perspective. So from a development perspective, typically the developers on the command line, they are much earlier in the process than an integration with Git or with CI/CD like I was showing in the interface there. In my case, I've got a command line here where I've recently run this Snyk test command. I'll run this right here and we'll see if this result actually comes out. But we'll see what's happening is I'm actually testing a Docker container for my command line as I'm building it out. We run Snyk test, we pass it the name of the container, and we pass it the Docker file. And what Snyk is doing is it's asking the package manager inside the container, what libraries have you installed? In the case of a Debian container, it's talking to D package. If it's Alpine, it's looking at APK, that sort of thing. Those are going to respond with the packages. We're going to ask our vulnerability database which versions of these libraries are vulnerable, and then we come back and we actually marry it up against the Docker file to give you information that a developer would be able to take advantage of. While it's testing, I'm actually going to scroll that up a little bit and show you what the results look like. We get results that look like this, where we can see, as this example here, I see this bin utils vulnerability that we've got here. And Snyk is able to tell me that bin utils has got a high level vulnerability, but it was introduced from my base image on this line right here. This is something that's pretty interesting to a developer because it tells the developer this isn't something that I directly did, running an installation command. It wasn't something that I copied into the container. This just came to be because I included a base that had this. This is as opposed to say this command up here, we see this vulnerability in bzip2 came in whenever my developer installed ImageMagick. So that tells the developer I can fix this easier. I just upgrade ImageMagick, I build from source, I do something like that. But looking back at the base image thing, Snyk takes this a step further as far as the remediation. And you might have noticed this earlier when we were sitting on here, but Snyk is able to tell us what the base image is. At this point, it's 10.4 for node. And we tell you, hey, high level rollup, you've got 950 total vulnerabilities inside this container. 92 of those are high severity. Snyk suggests a base image change out. If you change out your base image for something else, in this case, we see node 10.21 is a typically equivalent or a similar upgrade path that you can take, typically non-breaking. We take our vulnerabilities from 950 down to just a little over 660. If we do that, we also bring down our high severities down by almost 75%. It's a very, very substantial change from the vulnerability perspective for a very small change in our Docker file. Very simple to make, and the developer is early on in the process where this is cheap and easy to do. We're also so early in the process that if an application change needs to happen, if they need to tweak the app a little bit or install additional dependencies, that's also not too painful. And so Snyk goes even further than that with telling you alternative types. In this case, you see that we recommend an alternative node 14. This is a pretty major change from node 10, and maybe that requires some slight changes to our application. But if we can make those changes, then it's easier than fixing, say, 600 vulnerabilities. Then what we get by changing out to here is a pretty substantial vulnerability decrease. We go down to 53 from that 600 and getting down to a point where we're only at 3 Hive vulnerabilities. So again, a lot of bang for your buck on a very simple change, and that's the kind of information that Snyk is going to tell your developers on the command line. Okay, finally, I'm going to switch back over to the Snyk window here, and we're going to talk about what reporting looks like. So at this point, we're going to be wearing our administrative hats. These are the people who kind of want to look at the general health of our projects or the high-end security personnel, or we just want to know kind of where we stand across our entire organization. Snyk allows you to use the summary tab to kind of tell you that high-level overview. You know, information like how many total vulnerabilities we got across our entire org, how many issues have been fixed. These are things that Snyk has seen in the past and we're no longer seeing, that sort of thing. We assume that they're fixed. We see a burn down chart. You know, the black line represents projects that are being onboarded. The colored lines are vulnerabilities that are being detected. So you'd want to see the black line go up, colored lines go down. We can also filter on things like languages. So if you wanted to compare your .NET teams against your Golang teams, you could certainly do that. And then you can filter down to the manifest level if you wanted to just roll up a few manifests together and see how that project specifically is doing, kind of from a high level. The reporting is pretty flexible in regards to that. And we also allow you to look at historical data all the way back to a year. So you've got a lot of oversight on exactly how your organization is doing in regards to a security posture. The issues tab that we have allows us to look at all of the vulnerabilities that we have across all of our projects inside this organization from a high level. So we're able to do things like sort by the amount of projects. In this case, that's what I'm going to do here. And we can get maybe a prioritization look to know maybe where do we start our attack on fixing vulnerabilities. In this case, I can see, you know, project wise, hey, I've got 7 projects that are all affected by this single CVE that happens here. I can click on the 7 projects and it'll tell me exactly which of the projects are susceptible to this vulnerability. And then I can start working on it from that perspective. I can also do a search reverse ways. So if I had a CVE number first or a CWE or something like that, or maybe the name of an exploit, and I wanted to know, is there any projects in my organization that is susceptible to this vulnerability? I can put that into the search here, and then I'm able to kind of do a reverse lookup without having to ask each one of my project maintainers or other folks which libraries they're dependent on. I can know whether or not I need to fix anything here. The dependencies tab is sort of the same thing from the dependency perspective. So this is a bill of materials, and we can use this as a bill of materials, especially if you want to drill down into an individual project manifest or something like that. But we also get some other high level information out of here. We could do the same thing with sorting by projects, and this helps us with detecting or prioritizing where we want to fix. You know, in this example, we see, hey, we've got 7 projects again that are all affected by the C3PO library. There's a high level vulnerability there. That tells me that I probably need to do a fix on those because there's a lot of attack vector area there. We also are told some other information here. For example, this Antler project, we can see that this one doesn't have any high-level vulnerabilities. There's 7 projects that use it, and it hasn't been updated in 15 years. Not necessarily a vulnerability today, but from a high-level perspective, this tells me as an engineering manager, this is probably something that I would rather address sooner than later, because if a vulnerability comes out for this tomorrow, I'm not going to be protected by this. My maintainer of this package is nowhere to be found, and so it's probably better to replace this proactively. The last tab that I have here is licenses. We've touched very briefly on this, but in a nutshell, the licenses tab is going to give us a high-level overview on exactly which licenses are in use across my organization. The licenses, unlike a vulnerability where a CVE can dictate, or the CVSS score rather, can dictate the severity of it, a license is typically something that's going to be dictated by your organization. So if you determine that LGPL or GPL2 is not a valid license for our org because we only sell commercial software or something like that, you can flag that as a high-level vulnerability, and Snyk will tell your developers or tell anybody else that you're introducing a license issue that legal might not be happy with. This tab here is going to show us that general health across all of our projects. And so we can see, hey, we've got a bunch of GPL3 libraries that are out there. And we can see exactly which projects and which dependencies take that in. You know, do we have dual licenses, that sort of thing. And then every single one of these reports that we've seen can, of course, be exported as CSV, or they can all be had by querying our JSON API and getting standard responses back. And then you can pull them into your own reporting software, do that sort of thing. Okay, that's kind of it for the presentation at a really high level. I do have a handful of questions here that I want to go ahead and answer. And again, if there's anything else that you think of while I'm talking about these questions, feel free to throw them into the chat further and we will reach out and close those loops accordingly. So the first one I have is whether or not we have an API. We absolutely do. The API covers pretty much everything that we've seen here today. So onboarding projects, initiating tests, getting all these reports out, all of that can be done from a pretty standard JSON endpoint, JSON in, JSON out, and you get the information that you would expect. So programmatically, we actually have a lot of clients that don't use the interface at all, completely API driven. That's perfectly acceptable. How do we fix transitive dependencies? So we talked about this when we were looking at the reports earlier. Snyk is able to view the transitives because we build out the full tree, regardless of whatever that package manager is that you were using upstream. So we have the full picture of it. And because we have that full picture, we're able to fix the transitives by usually upgrading the direct dependency that those transitives are dependent on. If we upgrade the direct one to a version that we know doesn't have a vulnerable transitive down the line, then you're out of the woods on that issue. Okay, we've got a question about what our deployment models are and whether or not it's just SaaS. This is a great question, and the answer is no, it is not just SaaS. Snyk is able to actually deploy into 3 different methods. The first one is that we have an all SaaS-based offering, right? You use the Snyk console online, you connect to GitHub in the cloud or GitLab in the cloud, and that's perfectly reasonable. We have a lot of clients that do that. The second solution is kind of a hybrid solution. We have a tool we call our broker, which acts sort of like a proxy to allow Snyk in the SaaS solution to talk to on-premise code or other kind of repositories. So you would run the broker in your internal network, say you're using GitHub Enterprise or GitLab, something like that. Snyk can still talk to that by proxying through the broker internally. And then finally, we do have a full on-premise solution. If you want to utilize that, we have clients who actually use it in full air-gapped environments. There's of course some other constraints around running that. It's typically a little bit more complicated, but if that's what it calls for in your security posture, Snyk can absolutely address that issue. How are we dealing with Kubernetes nodes in Docker? In regards to Kubernetes, this is a little bit more of a complicated setup than some of the other Snyk work that we've got out here. Snyk actually sits inside your Kubernetes cluster and looks at your Kubernetes internal container registries for that vulnerable information. So when we did the Docker scan earlier, I was using my local Docker image, or the local Docker engine, excuse me, and looking at an image that was inside there, and that's what Snyk was scanning. We would do essentially the exact same thing when we're inside Kubernetes. So Snyk has a monitor that runs inside its own pod in Kubernetes that's isolated in its own work group, and then it scans the registries, and so it's going to be able to look at whatever the default images are that your Kubernetes cluster launches. This is pretty far into that right side of the SDLC. We would typically say, use Snyk earlier on in the process to make sure that those containers are being built safely, as opposed to that kind of deployment or production monitoring. But Snyk can absolutely run in that area as well. And that's especially useful if you're running containers in your Kubernetes cluster that you didn't necessarily build. Maybe there was no development process, and then you know whether there's vulnerabilities or not. Okay, I do have a handful of other questions as well, but we are running out of time, so I'm going to make sure that we get those all addressed kind of offline. And if there's any other questions in the meantime, feel free to reach out to us on chat or submit a question in any of the other ways, and we'll get back to you as soon as we can. I appreciate everybody joining the webinar today and hope you have a great rest of your weekend. Thank you so much.